In this video, I'm going to talk about a key identity that hyperbolic trig functions satisfy. So it turns out that hyperbolic cosine squared of theta minus hyperbolic sine squared of theta equals 1. And this is really similar to a key trig identity that we're really used to. So this is really similar to cosine squared theta plus sine squared theta equals 1. Okay, so I want to show why this identity is true and then try to motivate why these functions are called hyperbolic functions a bit. So let's remind ourselves what cosh theta and sinh theta were. So cosh theta is e to the theta plus e to the negative theta over 2 squared. And then minus sinh theta is going to be, I'll have e to the theta minus e to the negative theta over 2 squared. So if we square these, we'll get e to the 2 theta, and then I'll get plus 2 times e to the theta times e to the negative theta. That's just 1, so 2 times 1. And then I'll get plus e to the negative 2 theta over 2 squared is 4. And the next fraction, so I'll have that minus sign. If I square the next fraction, I'll get e to the 2 theta minus 2 plus e to the negative 2 theta. And on the bottom, I'll have 4, because 2 squared is 4. So when we subtract these fractions, a few terms cancel. E to the 2 theta will cancel with this e to the 2 theta, and e to the negative 2 theta will cancel with this e to the negative 2 theta, because we're subtracting. And then we'll get 2 minus negative 2, which is 4. And 4 over 4, that's 1. And that proves the identity that we wanted to show. Okay, so now I want to show something interesting about this hyperbolic identity and just the regular trig identity. So just in this regular trig identity, cosine of theta using the unit circle is x. So if we say x is cosine theta, and in the unit circle sine theta is y, if we say y is sine theta, then we get the equation x squared plus y squared equals 1. And graphing this, we get our xy axes, and this is the unit circle. It is a circle centered at the origin of radius 1. So to be a little bit more technical, what we've done here is we've parameterized this equation, this unit circle equation, by saying x is cosine theta and y is sine theta. Let's do something similar for this hyperbolic identity. So for this hyperbolic identity, if we do something similar, if I say if x is hyperbolic cosine of theta and y is hyperbolic sine theta, what do we get? So we will get, we get the equation x squared minus y squared equals 1. So because of this minus, this graph is not going to be a circle. Its graph, okay, actually let me draw my axes here. Let me draw my axes, and now let's draw the graph. The graph of this is actually going to be a hyperbola. Actually, technically, it's going to be part of a hyperbola. So I'm going to draw one part of the let's draw that in purple, actually. All right, so let's draw that in purple. And it'll turn out that this part of the hyperbola, it goes through the point 1, 0. We actually just get this part of the hyperbola. We get part of the hyperbola. There's also a part on the left-hand side, which I'll draw with a dashed line. So that looks like this. But we actually don't get that part of it. And I'll talk about why. So this part on the left, which we actually don't get here, would be negative 1, 0. And the reason we don't get that left-hand part is because our x-coordinate here was given by hyperbolic cosine. And hyperbolic cosine is always greater than or equal to 1. If we think back to the graph that we had of hyperbolic cosine, the output is always at least 1. So hyperbolic cosine is always greater than or equal to 1. And in this case, we're saying hyperbolic cosine is equal to x. So that means that x has to be greater than or equal to 1. And that's why we're just taking this right-hand part of the hyperbola where x is actually greater than or equal to 1. Okay, and the fact that we got this hyperbola, technically part of the hyperbola, is why these are called hyperbolic functions. Hyperbolic functions. All right, so that sort of motivates why they are named hyperbolic functions.